Guys, what's up? My name's Pragya and you're watching my channel Easiness Dentistry. So in this video, we are going to consider the chapter in systemic pharmacology, which is drugs acting on autonomic nervous system, special consideration to cholinergic and anticholinergic drugs. Okay, so let's get started on this chapter. Okay, yeah, so the next slide. Firstly, let's see what we are going to study in this particular video. Firstly, we are going to classify ANS, autonomic nervous system, and then we are going to see what neurohumoral transmission is. Okay, how the nerve impulses transmit from one neuron to the another one. Okay, so let's first classify the nervous system. So we know that it is having two parts, CNS and peripheral nervous system, central nervous system and peripheral nervous system. And we know brain and spinal cord, they are both included in central nervous system. Now PNS, it's having both motor and sensory parts, right? Now the main nervous system we are having right now in this video, about which we are going to see, it's autonomic nervous system, which is basically involuntary action. Okay, so सारे involuntary actions ANS संभालने वाला है, right? Somatic nervous system is also there, which is again part of PNS. It is voluntary in action. Okay, so voluntary actions somatic करेगा and involuntary ANS करेगा. So both of these are again classified. These are parts of peripheral nervous system. Now ANS is again divided into parasympathetic, sympathetic, and enteric. Okay, so enteric we are having along with parasympathetic and sympathetic. So some of these organs, they are receiving only parasympathetic, some only sympathetic, and enteric is totally different, which is receiving both parasympathetic and sympathetic. Okay, so ANS, it is involuntary and it's divided like this. Okay, so that's what this slide tells us here. Okay, now firstly, blood vessels, spleen, sweat glands, and hair follicles, they receive only sympathetic. Okay, so they are receiving only sympathetic nerve supply, right? Blood vessels, spleen, sweat glands, and hair follicles. Okay, most of the organs, they are receiving from both parasympathetic and sympathetic. So we are studying exclusively which organs are there which are receiving only sympathetic or only parasympathetic. Okay, cool. So ciliary muscles, bronchial smooth muscles, gastric and pancreatic glands, they receive only parasympathetic. So that's what I was talking about. Okay, now we know that hypothalamus, it regulates autonomic function, right? Now it is having two nuclei, posterior and lateral nuclei, and anterior and medial nuclei. So posterior and lateral nuclei, what's doing, it's regulating the sympathetic function, and the anterior and medial, it is regulating the parasympathetic function. Now the enteric nervous system, we saw this, right? This is again part of ANS, है ना? And it receives input from both sympathetic and parasympathetic, and it integrates bowel movements as well as it regulates secretion and absorption. Okay, so it is again a different kind of a nervous system where it is receiving both parasympathetic and sympathetic, and basically it's for regulating the bowel movements. Okay, and secretion and absorption from a gut. Okay, now if we talk about our second topic, which is neurohumoral, it's humoral. Okay, HUMORAL. Now it's neurohumoral transmission. If we talk about this, that how impulses are transmitted from one neuron to the other one. So if you see this particular image, we are having some synaptic vesicles which are carrying neurotransmitter, and the presynaptic junction is there and the postsynaptic junction is there. Okay, and we are having some voltage gated calcium channels, the pink colored, and we are having a neurotransmitter transporter. Okay, then on post junctional membrane we are having some kind of receptors, okay, which are going to receive these transmitters when they are released. Okay, so we'll see this neurohumoral transmission step by step. Let's see what it is. So it is basically the nerve transmit their message across the synapse and neuroeffector junctions by release of some chemicals which are messengers. Okay, so these chemicals called as transmitters, they release from one they released from these vesicles. Okay, and then they act on the receptors so that the message can be transmitted. Now the 5 steps we are having in neurohumoral transmission, which is first one, impulse conduction, transmitter release, transmitter action on post synaptic membrane. So what happens is, फर्स्टली इम्पल्स कंडक्ट होगी, राइट. इम्पल्स जैसे ही आएगी ट्रांसमीटर रिलीज होगा, ओके, फ्रॉम द वेसाइकल्स, सिनेप्टिक वेसाइकल्स. ओके, ट्रांसमीटर रिलीज होगा, देन व्हाट विल हैपन, ट्रांसमीटर एक्ट करेगा पोस्ट सिनेप्टिक मेम्ब्रेन पे जाके. ओके, देन व्हाट विल हैपन, पोस्ट जंक्शनल एक्टिविटी विल अकर. ओके, जैसे ही वो एक्ट करेगा तो कुछ एक्टिविटी होने वाली है पोस्ट जंक्शनल मेम्ब्रेन पे, एंड देन व्हाट लास्टली व्हाट विल हैपन, टर्मिनेशन हो जाएगा ट्रांसमीटर्स का. ओके, so these are the 5 very very important steps, and we are going to look at each of them. Okay, so firstly, let's see what is impulse conduction, right? So impulse conduction, it is having 3 steps basically: polarization, depolarization, and repolarization. So what happens in polarization, here resting membrane potential is minus 70 millivolt, right? So here you can see resting membrane potential is minus 70, and why it is minus 70, due to high potassium or the negative ions inside the axon. Okay, and more sodium ions outside the axon. So that is what happens in polarization. And here also high potassium permeability is there of the axonal membrane, right, and low sodium permeability. So that point also needs to be considered. So what happens is high potassium inside, more sodium outside, and high potassium permeability and low sodium permeability. Okay, and minus 70 millivolt potential we are having in polarization. Now what happens in depolarization and the overshoot reverse polarized. So depolarization is also called as overshoot. I mean, it get turns into overshoot reverse polarization. Okay, so what it is caused when an electric impulse arrives. Okay, so जैसे ही कोई electric impulse आती है उससे क्या होता है, sudden increase in sodium conductance potential. So suddenly sodium की जो conductance है, उसकी जो permeability है, it increases. Okay, and plus 20 millivolt हो जाता है potential in this case. We'll understand this again with a diagram, don't worry. So just go through the theory once. Okay, and repolarization में क्या होगा, K plus ions move out in the direction of concentration gradient, and ionic distribution is normalized by sodium potassium pump. So let's see this diagram. Okay, we are having first one. फर्स्ट वन में क्या दिख रहा है आपको, पोलराइजेशन, नॉर्मल पोलराइज्ड मेम्ब्रेन है, माइनस चार्ज इनसाइड ड्यू टू नेगेटिव ऑर्गेनिक आयंस एंड पॉजिटिव चार्ज आउटसाइड ड्यू टू सोडियम आयंस. ओके, दैट्स व्हाट वी सॉ. एंड yeah, so that's what potassium के लिए we are having uh, we are having more permeability for potassium and low permeability for sodium. So here you can see more potassium are coming out and less sodium are going in. Okay, so permeability is more for potassium. Then when the stimulus is applied, see the B1. Okay, B diagram, and when the stimulus arrives. Okay, जैसे ही stimulus आता है, depolarize हो जाती है membrane. That means the orange colored one, positive from inside and negative from outside. Okay, so here what happens is sodium के लिए permeability बढ़ गई है, right? तो sodium जो कि बाहर ज़्यादा था, it will come in, right? And उससे क्या होगा, अंदर positive charge आ जाएगा and membrane will depolarize. It will get depolarized. Now that's what we saw, what is depolarization. Okay, here अंदर negative charge हो जाएगा which is plus 20 millivolts. Okay, and then we will see what repolarization is. Now this depolarization, it ये आगे से आगे ट्रांसमिट हो रहा है, राइट. यू सी द ऑरेंज कलर्ड वन, इट इज़ गोइंग फर्दर एंड फर्दर. ओके, और वो जैसे जैसे आगे जाता है उसके पीछे का जो पार्ट है, इट गेट्स रीपोलराइज्ड. ओके, जहाँ पे डीपोलराइजेशन हो चुका है, सो इट अगेन गेट्स बैक टू इट्स नॉर्मल स्टेट, राइट, विच इज़ नेगेटिव फ्रॉम इनसाइड एंड पॉजिटिव फ्रॉम आउटसाइड. एंड हाउ इट अकर्स, बाय पोटेशियम आयन मूवमेंट, ओके, कॉन्सेंट्रेशन ग्रेडियंट के हिसाब से पोटेशियम आयन मूव कर जाते हैं, सोडियम पोटेशियम पंप एक्टिव हो जाता है, and that's how again polarization state is achieved. So these are the three basic processes which occur in impulse conduction, right? Now the second one, okay, transmitter release. Now what happens here is neurotransmitters, they can either be excitatory or inhibitory, and they are stored within synaptic vesicles in pre-junctional nerve endings. We saw the diagram, right? The neurotransmitters, right? One sec. This diagram. So neurotransmitters, these are stored in synaptic vesicles, okay? And right, so these are stored in the pre-junctional membrane, right? So okay, then these can either be excitatory or inhibitory. That's what you need to consider. They can either excite the nerve ending or they can inhibit the receptor, right? So the calcium entry, what it does, so we were having some calcium and channels right there, and they fluidize these calcium entry, it fluidize vascular membrane, and the and all the contents from the synaptic vesicle, which is transmitter proteins and enzymes, they are excluded by exocytosis in junctional cleft. So we were having a cleft between a presynaptic membrane and the postsynaptic, the post junctional membrane. So we were having a cleft in between. In that cleft, it is released, which what is released, the transmitters, the enzymes, all that content of the synaptic vesicle. And how it is released? Because due to exocytosis, okay. And calcium, what is the role of calcium here? It fluidizes the membrane so that it can be released, okay. Now the release process, it can be modulated, okay, it can be altered, it can be yeah, it can be modulated through activation of specific receptors on pre-junctional cell membrane by transmitter or the other agents. So basically in pre-synaptic pre-junctional cell membrane, we are having some receptors, okay, and then the transmitters which are released in the cleft, they again act on those receptors on the pre-junctional membrane, and they can modulate this process, that either more can be released or less can be released, right? So here you can see it, okay. Calcium channels are there. Calcium is coming from uh, extra axonal space to the inside of the axon, okay. And synaptic vesicles we are having, okay. They are exocytosing, and the transmitter is released in the area there, this the cleft one, synaptic cleft. And okay, so the first step we saw was action potential reaches axon terminal and depolarizes the membrane. तो जैसे ही ये होता है कि एक्शन पोटेंशियल रीच हो जाता है, ओके, डीपोलराइजेशन हो जाती है मेम्ब्रेन की, तो तभी कैल्शियम गेटेड चैनल्स ओपन हो जाते हैं एंड कैल्शियम फ्लोज इन. तो कैल्शियम ट्रिगर करता है वेसाइकल्स को कि न्यूरो को रिलीज करो, इट फ्लूइडाइजेस द मेम्ब्रेन. देन द न्यूरो दे बाइंड टू द रिसेप्टर ऑन द टारगेट सेल, and this case they cause a positive ions to, okay. तो ये जो न्यूरोट्रांसमीटर है जाएगा पोस्ट सिनेप्टिक मेम्ब्रेन पे जाएगा, पोस्ट जंक्शनल मेम्ब्रेन, एंड इट इज गोइंग टू बाइंड टू द रिसेप्टर एंड कॉज द इफेक्ट, okay. Now the third step, which is translator action on post, it's basically transmitter, okay, transmitter action on post junctional membrane. What has happened to my spelling here? So a released transmitter, it combines with receptor on post-junctional membrane and induces excitatory or inhibitory post-synaptic potential. So जैसे ही ट्रांसमीटर पहुंचता है पोस्ट जंक्शनल मेम्ब्रेन पे, वो दो चीज़ें कर सकता है, या तो एक्साइट करेगा या इनहिबिट करेगा, राइट. सो it is going to combine with the receptor and it is going to induce either excitatory or inhibitory post synaptic potential. So दोनों में क्या क्या होता है, what happens in excitatory and what happens in inhibitory synapse. So excitatory synapse में basically permeability बढ़ जाती है सोडियम के लिए. So sodium comes in, and you know that when sodium comes in, depolarization occurs, okay. So what we studied till now was excitatory synapse. Now what happens in inhibitory synapse? Here permeability, for example, we are having GABA here. GABA is a transmitter which is basically which inhibits, okay, and glutamate it excites, okay. So we are having just examples here. So what is going to happen? Chlorine या फिर negative ions, right? uh, ऊपर भी excitatory में sodium या फिर positive ions like potassium can can come in, and chlorine when they so basically permeability increases, okay, for negative ions, and what it causes hyperpolarization. So that is what transmitter action on post junctional membrane, it can either excite or it can inhibit. Now the fourth step, which is post junctional activity, okay. So what are the transmitters going to do on the post junctional membrane? So basically a supra threshold excitatory postsynaptic potential, it generates a nerve impulse. So basically what you need to consider is supra threshold, okay. So it should be more than the threshold level, right? Only then the impulse is going to get generated. Other than if the threshold level is not reached due to the stimulus, then the nerve impulse won't be generated, right? So supra threshold excitatory potential should be there, and it can cause either contraction in the muscle or it can cause secretion in the gland, depending on what part what organ it's acting, okay. So and IPSP, it stabilizes post-junctional membrane and it resists depolarizing stimuli. So this is what happened in EPSP, okay, excitatory potential. Now what happens in inhibitory potential? So अगर inhibitory potential आता है, stimulus आता है, inhibit, if the transmitter is going to inhibit, for example GABA we are having, so what it does, it stabilizes post junctional membrane और वो depolarization को होने से रोक लेगा, right? So that is what happens in inhibitory one. Now the fifth step, which is termination. So it either locally degrades the transmitters which are released, for example acetylcholine, it is either locally degraded or it is taken back into pre-junctional neuron by active reuptake or diffusion. Okay, so you got it, कि diffusion से या फिर actively उसको वापस ले सकते हैं pre-junctional neuron में, प्री जंक्शनल मेम्ब्रेन के थ्रू, राइट, या फिर लोकली डिग्रेड कर देंगे एस्टरेजेस. नाउ द रेट ऑफ टर्मिनेशन, इट गवर्न्स द रेट एट विच रिस्पॉन्स कैन बी ट्रांसमिटेड. वी नो दैट कि जितना जल्दी टर्मिनेट होगा उतना ही जल्दी रिस्पॉन्स भी ख़त्म हो जाएगा, ठीक है. तो दैट इज़ वॉट रेट ऑफ टर्मिनेशन शोज अस. Now if we look why termination occurs, okay, so basically it is to ensure that only one action potential is generated across the muscle membrane and transmitter action must be brief, okay. So transmitter का जो action है वो थोड़े टाइम तक रहना चाहिए. For example stimulus आई अभी और transmitter act किए जा रहा है, right? So it can cause multiple action potentials, but that should not occur, right? If one stimulus is there, then only one action potential needs to be generated. So we need to destroy the transmitter once generated. So that is what does by acetylcholine esterases. So these work for acetylcholine, they destroy the acetylcholine. So what they do is they convert acetylcholine into, they degrade into acetate and choline, okay. So that is what termination of transmitter is, okay. So let's go for a quick recap. What we saw in this video was, firstly we classified nervous system, okay, right. We let's just one second, yeah, we classified nervous system CNS, PNS, and we classified ANS, okay. Then we saw that few organs are there which receive only sympathetic and few are there which receive only parasympathetic. We know the hypothalamus role. What about enteric? And we then saw the neuroimmunal humoral transmission, okay. So how it occurs, the 5 steps it's having. The first one, impulse conduction, the 3 processes occurring here, okay, how they're occurring, the transmitter release, okay. So how transmitter is released, how it acts, then how it acts on post junctional membrane, it either can excite or it can inhibit. then the fourth step, post junctional activity, and termination. Okay, so this is it, guys. If you like this video, if you found this helpful, do not forget to like, share, and subscribe. It may not mean for you anything for you, but obviously it's very very important for me. Yeah, so thank you for watching this video, and keep studying, keep watching this channel, and thank you so much.